Hi and Assalamualaikum. We are from Group D6 and as chemical engineers, our team will explain about substitute material production of natural rubber, which is the thermoplastic elastomer or TPE. Thermoplastic elastomer (TPE) is a flexible and rubber-like material that can generally be processed by a few methods. One of the processes that are available in the production of thermoplastic elastomer (TPE) are dynamite vulcanization. The thermoplastic vulcanizates are prepared by mixing and shearing a thermoplastic polymer, a vulcanizable elastomer, and a curing agent. The vulcanizable elastomer is dynamically cured during the shearing and mixing and is intimately and uniformly dispersed as a particulate phase within a continuous phase of the thermoplastic polymer. The method of preparing the thermoplastic elastomer through dynamite vulcanization proposed in the present invention is as follows. First, preparing of reactive step material. Part rubber, plastic, filler, tenderizer, aging agent and processing aids are carried out by the melt blending granulation and wherein rubber accounts for the 10 to 70% of rubber gross weight in the prepared thermoplastic elastomer. The second step is preparing of vulcanizing agent rubber master batch with vulcanizing agent and the granulation of part blend rubber, wherein rubber accounts for the 20 to 60% of rubber gross weight. The third step is preparation of promoter rubber master batch with promoter and the granulation of part blend rubber, wherein promoter accounts for the 5 to 30% of rubber gross weight. The fourth step is dynamite vulcanization. One step of reactivity material, vulcanizing agent rubber master batch, the promoter rubber master batch of above mentioned three-step preparation are mixed into sulfuration of action additive. Dynamite vulcanization is a widely used method to prepare thermoplastic elastomers comprising partially or fully cross-linked elastomer particles in melt-processable thermoplastic matrix. Thermoplastic vulcanizates are prepared by melt mixing the elastomer and thermoplastic in an internal mixer or in a twin screw extruder. In the second step, vulcanizing agents such cross-linkers of curatives are applied after a well-mixed mixture has formed. As the mixing process continues, vulcanization of the rubber polymer occurs under circumstances of high shear and high temperature.
Next, the thermoplastic polymer used in the present invention is a solid plastic resin material. Preferably, the resin is a crystalline or semi-crystalline polymer resin. More preferably, a resin having a crystallinity of at least 10% as measured by a differential scanning calorimeter. Polymers with high glass transition temperatures, such as amorphous galactic engineering plastic, can also be used as thermoplastic resins. The melting temperature of this resin is generally lower than the thermal decomposition temperature of the elastomer. Accordingly, both polar and non-polar polymers can be used in the present invention. As used here in a thermoplastic polymer or thermoplastic resin or engineering resin comprise two or more different thermoplastic polymer or one or more compatibilizer and two or more thermoplastic polymers. In the thermoplastic vulcanizate reaction processes, thermoplastic components are typically added or fed to the melt process equipment in the form of pellets or powder to improve physical mixing at the feed pot, while the cross-linkable elastomer is added in the form of small pieces, granules, or ground particles or pellets. Is often covered with a filler or semi-crystalline polymer powder. Alternatively, both the thermoplastic and the elastomer may be fed directly in the molten form together or separately. Curing materials or curing agents, curing metal plus adjuvant of the present invention in which elastomer can be used for crystalline or vulcanization include silicon hydride, phenyl resins, peroxide, free radical initiators, sulfur, metals, any of those known to those skilled in the art of processing vulcanizable elastomer. More specifically, thermoplastic vulcanizers, including zinc compounds, and the like may be used. The above cured material The above cured materials are often used with one or more adjuvants that act as initiators, catalysts. To improve the overall cured state of the elastomer, the cured material may include the melt hopper, extruder feed hopper, and may be added to at one or more locations. Further, the produced TPV may be finished by pelletizing by a method known as a method for plastic pelletization. Such pellets advantageously contain rubber particles that contain a minimum amount of the original thermoplastic material. In example, 1 to less than 18 weight percent thermoplastic polymer based on the total amount of the thermoplastic material and non-oil extended rubber. Because it can be used as a containment intermediate, the added thermoplastic, whether the same, similar, or completely different, can be added to the subsequent blending step of the same or additional extruder. Other additive or modifier can be added in this manner as well.
Assalamualaikum warahmatullahi wabarakatuh and good morning. Today, I would like to present about three main process equipment in the production line and elaborate on the working principle of this equipment, which is a temperature, pressure and flow rate. By the way, my name is Siti Umairah. First of all, many of the equipment used in this process, which is conventional masticating equipment, for instance, bend-burr mixer, fabrication equipment, and double screw extruder. Ethylene octane copolymer, which is POE, and polypropylene, the name of PP, become thermoplastic elastomer, TPE, by dynamic vulcanization technology. Since it is conventional thermoset rubber, it can be processed on thermoplastic fabrication equipment. Generally, the hard domains will undergo dissociation at elevated temperature. When it was cool, the hard domains again solidify and provide tensile strength at normal use temperature. Thermoplastic rubber dynamic vulcanization, which is TDV, undergoes melt, blending and grafting reactions during a pelletizer's reactive extrusion. The temperature during melt blending is 260 degrees Celsius, while the grafting reaction is more or less than 160 degrees Celsius. The viscosity decays with an increasing shear rate. The process employed in the fabrication of the melt flow rate meter involve marking pipe for the barrel and cutting to size, machining a cover plate, and welding. The melt flow rate, which is MFR for virgin, was calculated to be 20 gram per minute, and that for 100% recycled polypropylene was 40 gram per 10 minutes. This wide difference between the MFR of the virgin material and 100% recycled PP occur as a result of the presence of plasticizers in the recycled material and small effect of degradation of the material. Another equipment used is a bend-burr mixer. The maximum pressure in the membrane mixer is 6.6 kg per centimeter square. Temperature based on the operation is 6.6 kg per centimeter square before oil addition to 4.5 kg per centimeter square after oil addition. The temperature in each step changes simultaneously. Initially, the temperature is 350 degrees Celsius and the mixer speed is set at 55 rpm and the ramp pressure is at 135 bar. Then the mixing starts. Then the temperature goes to 1050 degrees Celsius and the ramp pressure decreases to 110 bar. After the mixing complete, the temperature in the mixer is 1300 degrees Celsius and discharge time after the ramp float is 10 to 12 seconds. For activator, it is using zinc oxide and stearic acid. A temperature control unit, which is TCU, is present for temperature control of the mixer. 3 motors are present for the drop door, rotors, and body for temperature control. The drop door is operated by a lock. The complete mechanism is operated by hydraulic. The pressure required to open it is 800 kilopascal. Most membrane mixers have 2-wing rotors, but for the latest now, 4-wing designs have been developed for faster mixing. So our product will produce more rubber directly proportional to time using a 4-wing design. The last equipment that we use is the double screw extruder. Rubber grade and thermoplastic resin are combined by passing them through a mixer 40 that simply stirs at low speed to create a compound. The compound is then placed in a double screw extruder tank where the compound is sheared together using the double screw extruder tanks. Strong shearing force to create a blend composition. The double screw extruder test barrel temperature is adjusted at 190 until 230 degrees Celsius and the screw speed is 350 rpm. The rubber is provisionally scattered to micron order in resin by this pre-disperse method. Thank you.
Now, I would like to talk about the challenges that we are facing in production of thermoplastic elastomers. In process dynamic vulcanization, we face the challenges which is the change in the physical properties of thermoplastic elastomers. When dynamic vulcanization is performed on thermoplastic elastomers, the thermoplastic elastomers shrinks while retaining its original shape. Vulcanization essentially scales down rubber to a smaller size, all without deforming or altering its shape. For the anionic polymerization, we face the challenges which is high capital costs. Initial costs are high due to the design, testing, and tools required in this process. Next, the challenges that they are facing in process carbocationic polymerization is it tends to become soft material that eventually burns. When it's exposed to high temperatures, it will melt down and become soft and tend to burn. And the challenges they are facing in the process polyaddition is heat transfer and mixing become difficult as the viscosity of reaction mass increase.
Despite having a lot of the challenge on the thermoplastic elastomer industries, thermoplastic, or known as a TPE, has become a significant part of the elastomer industry since they were first produced in about 55 years ago, and it is known for its versatility and recyclability. As time goes by, sustainability development of the TPE industry has grown significantly and become more and more approachable towards society, economic, and environment. On the society side, TPE industry has known for contributing on the job opportunities toward the communities because of its wide range process and responsibility. TPE plays a huge part on maintaining our needs day by day, replacing the traditional rubber industry. The flexibility of TPE can be customized to make a lot of product is crucial to make life better. As the economy become more and more advanced and the sustainability became more essential in covering economic nowadays, the thermoplastic elastomer does not run away from this path because it is viewed as a cost effective as they demand less energy to manufacture. TPE needs less processing and be made faster than other materials. TPE is also investigated worldwide as a potential replacement material for the rubber and a plastic good. When it comes to the environmental consideration, thermoplastic elastomer has a wonderful opinion. Because they are recyclable, thermoplastic elastomer are seen being environmentally friendly. Using less product does not need a lot of material to make a TPE. TPE is one of the eco-friendly products you can find on the market. After being altered properly, TPE also consists of fire-resistant materials of a nature and the nature of chemical resistant, making a high durability and the quality can be last longer to reduce the consumption of an excessive plastic. It is proven that TPE can be a great substance compared to a traditional rubber. Despite having a lot of benefit from it, we must remember that all what we do today can affect on what will happen on the future. Wise thinking and making the right act on a crucial moment can be really determine everything. Thank you.